right. Let's talk about something that is literally everywhere. It's in our homes, our cars, our clothes, and as we're about to find out, even inside our own bodies. I'm talking about plastic. Today, we're going to get into the mind-blowing scale of the plastic waste crisis, uncover some of the hidden dangers, and then we'll look at the incredible ways people are fighting back, from simple community projects to some seriously futuristic science.
Okay, so let's just jump right in with a question for you. And I mean you, personally. Let's forget about the huge landfills and the oceans full of trash for just a second. Just think about your own body. From the food you eat, the water you drink, maybe even the air you're breathing right now, how much plastic do you think you're taking in every single week?
The answer is about 5 grams. Yep, you heard that right. To put that into perspective, that's basically the weight of a credit card. You are eating a credit card's worth of plastic every single week. So yeah, this isn't some distant environmental problem anymore. It's personal. It's inside all of us.
So how on earth did we get to a point where we have a credit card's worth of plastic inside of us every week? Well, to understand that, you first have to understand the absolutely staggering scale of the global plastic problem. Let's look at the numbers. Every year, humanity produces over 4.9 billion metric tons of plastic waste. I mean, that's a number so huge it's almost meaningless, right? It's a mountain of plastic that shows just how dependent we've become on this stuff. But the real question is, what happens to it all? And this is where this story takes a pretty dark turn. You see, of all that plastic waste, we only recycle a tiny little fraction of it, just 9%. So what about the other 91%? Well, it gets buried, it gets burned, where it ends up blowing into our forests, our rivers, and our oceans. It's a huge systemic failure, really, because a lot of plastics are just too complex or too contaminated to recycle easily, and we just don't have the systems in place to handle it.
And here's the scary part. This problem is accelerating. If we just keep doing what we're doing, the projections show that by the year 2050, there will be about 12 billion metric tons of plastic junk just sitting in landfills or floating around in nature. That's a legacy of trash that will outlive all of us by centuries.
You know, the plastic bottles and bags we see tangled up on beaches, that's really just the tip of the iceberg. The far bigger danger might be the plastic we can't see. The stuff that's broken down into microscopic, invisible pieces.
We're talking about microplastics. These are tiny little fragments, smaller than a grain of rice, that break off of larger plastic items, and they have now infiltrated every single corner of our planet, from the highest mountains to the deepest oceans, and as we've already covered, they're in our food, our water, and our bodies.
So, what's the big deal? What does having this stuff inside us actually mean for our health? Well, the science is still emerging, but the early findings are pretty concerning. We're seeing links to things like cellular damage, DNA damage, disruptions to our immune system, and even a potential for increased cancer risk. And here's the kicker, it's not just the plastic itself. See, plastics are made with a whole cocktail of chemical additives to make them flexible or fire-resistant. And what happens is, these tiny microplastics act like little Trojan horses, soaking up those chemicals and other pollutants from the environment and carrying them directly into our bloodstream and our organs. Okay, I know, that was a lot of bad news. But the story absolutely does not end there. Because now that we know how big the problem is, we can talk about the solutions. And there is some amazing, ingenious stuff happening out there, from tiny communities to huge global initiatives. So when we talk about recycling, there are kind of 2 main paths. The traditional way, which is what we mostly do now, is just melting down plastic and remolding it. It works, but you need really clean, well-sorted plastic. But the new frontier is chemical and biological recycling, where you can actually break plastics back down into their original chemical building blocks. This can handle all sorts of mixed, messy plastic waste, but the tech is still pretty new. To see what innovation looks like in the real world, let's head over to Palembang, Indonesia. There's this incredible organization called the Indonesia Waste Bank, and it's just a perfect example of a community deciding to take charge, turning their local pollution problem into a real opportunity. And this picture, it really says it all. You see the community getting this plastic shredder. That machine is more than just a piece of equipment. It's a tool for empowerment. It's what allows them to start the process of turning worthless trash into a valuable resource for their own community. And the process they came up with is just genius in its simplicity. First, they shred all the plastic they've collected. Then, they mix those little plastic bits with sand and cement. They press that mixture into this cool, unique triangular mold, and what comes out is a strong, lightweight, and eco-friendly building brick. It's amazing. So,
That kind of community-led innovation is just so inspiring, right? But what if we could take it even further? Now let's look at the cutting-edge science that's trying to completely change the game, turning waste plastic into high-tech, super valuable materials through a process they call valorization.
This right here, this is the ultimate goal, a truly circular economy. Valorization isn't just about recycling plastic into another bottle. It's about upcycling it into something better. Imagine turning old grocery bags into graphene for new electronics, or old water bottles into advanced filters that can clean water. Waste stops being an endpoint and starts being a beginning.
So how do you actually turn this trash into treasure? Well, two really cool methods are leading the way. One is called pyrolysis. You basically cook the plastic at a super high temperature without any oxygen, and it breaks it down into a liquid oil and gas. The other is biotechnology, where scientists are designing special enzymes and even microbes that literally eat plastic and break it down into its pure, original components.
Now this all sounds incredible, but we have to be realistic here. We're not quite there yet. There are some major hurdles. Right now, these processes aren't always super efficient, and they can be really expensive, often more expensive than just making new plastic from oil. We still need to figure out how to scale this up and build the infrastructure to support it.
And that really brings us to the final and maybe most important question. We've seen that the solutions are out there. From a simple break in Indonesia to a complex chemical process in a lab, the technology exists. We can solve this. The real question is, do we have the will to do it? Are we, as a society, ready to make the changes in policy, in industry, and in our own lives to make it happen? The next chapter, well, that's really up to us.